So hello everyone, this is lecture 4 for the atomic physics. In the last lecture we were discussing about the questions based on the Bohr's model, and today also we will discuss some more questions. In case means this is the scene that where we are discussing all kind of questions which can be asked from the Bohr model. So you won't have any doubt. So these are all the previous year questions. So you must pay the very much attention here. So show that for large quantum number n, the mechanical orbital frequency is equal to frequency of photon which is emitted between the adjacent levels. So what they are saying that we need to prove that frequency of this electron is equal to the frequency which is of the radiation which is emitted when electron is going from the in the transition from the higher level to lower level when n is very high. So what is the meaning of frequency? Frequency means how many cycles or round electron is doing per second in this orbit. So these are number of cycles completed by an electron in its orbit per second is called the mechanical orbital frequency. So you know what is the radius Rn. So what is this complete distance? This will be 2 pi Rn divided by the speed of the electron is Vn. This will give you time, and 1 upon T will give you frequency. Now you know the expression for Vn and Rn. We already derived them. So we'll substitute them, and here we will get this kind of thing, and this is nothing but this is your Rydberg constant R infinite. So this will be your frequency. Now we calculate the frequency of this by this method, by Bohr's method. Now we need to see that if the transition frequency is same or not. So let's calculate the transition frequency. So the radiation will be this, means R energy En plus 1 minus En will give you the frequency emitted, and now you can calculate this frequency. So first we need to substitute these expressions. So let's do that. So En plus 1 will be equal to minus R infinite Sc z square by n plus 1 square, and this will be minus, and minus will give you plus here. So R infinite Sc by n square z square, this is equal to h nu. Now take the R infinite Sc z square common, this will give you this expression. Now we will just take the LCM and do this. So here this n square will cancel out, and 2n plus 1 will give you 2n because n is very large, and here also n plus 1 will give you n because n is very large, n4. It will be 1 upon n cube in the denominator. So you will get frequency equal to this, and this expression is same what we get here. So now you have proved that both frequency will remain same. Next question is for high principal quantum number n for a hydrogen atom, the spacing between the neighboring energy levels is proportional to. So this was the question was asked, means the frequency is proportional to what. So you can see here there were options were given like 1 upon n, 1 upon n square, 1 upon n cube, 1 upon n4. So you can directly see that we already solved this. So it will be 1 upon n cube. So you can solve it the same way. Next question is the energy of an electron in ground state of helium atom is minus 79 electron volt. So this is, we are talking about helium atom, must consider this. Considering the Bohr model of the atom, what would be the 10 times the first ionization potential for a helium atom in units of electron volt? Now what is the meaning of ionization and what is first ionization? So this is your helium atom, 2 protons here and 2 electrons in the orbit. Now if you remove this first electron, this will be your first ionization, and if you remove after that this second one, this is called a second ionization. So we need to find the energy required to remove this first atom, means first ionization potential of helium atom, and we call the energy required to remove the first one is E1, and then after when this one is removed it will become helium ion like this. Then this will be your second ionization to remove this, we call it as E2. So E1 plus E2 will give you your ground state energy of helium, that will be this. Now this energy is already given, that is minus 79 equal to E1 plus E2. Now see this helium ion is acting like the hydrogen like atom because this have one electron in the orbit. So we can apply the formula for energy to this atom or the ion, but not to this. So we can calculate the E2, but then if we have E2, then E1 can be calculated using this expression, because E2 is can be calculated and this is already given, E1 will be calculated then. So how to calculate E2? So we know for this hydrogen like atom we can apply the formula, that is R infinite Sc by n square z square. So z is 2 and n is 1. So this will give you the energy or the E2. Substitute E2 here and E1 will be this, minus 24.6 electron volt. Now you can calculate E2 also from directly here, this will be this. And they ask the 10 times of this E1, so 10 times of this will be 246 electron volt. So this is the energy, and the ionization potential means the energy required to remove this, so that will be positive, plus 246 electron volt. Now see this E2 is more negative than this E1. So why is that? Because when the one electron is removed, then the other one will be more strongly attached to the helium atom because of the less screening. So we will understand the screening in the next question. Given that ionization energy of hydrogen 1H1 and 3 lithium, 13.6 means the ionization energy of hydrogen and lithium is given, that is 13.6 and 5.39 electron volt respectively. We need to find the effective nuclear charge experienced by the valence electron of lithium atom, and we need to estimate it in terms of the E. So first let's understand what is screening is. If there is this proton and these are the electrons, then whatever the charge means, whatever the force is this electron is feeling from this charge is different what this electron is experiencing. Means this electron will feel less force as compared to this, because the screening means these electrons will form the cloud here, and the force between these will be less strong as compared to this. This is called the screening effect. And we know that how can you find the force. Means the potential for this electron can be calculated using this formula. You don't need this formula here, but just for your information I am giving you this formula. Means normally this is your potential, but this exponential term will give you the less force for this far electron. Okay, so if for the hydrogen we will see, then there is no inside electron, and we will see that force will remain same and potential will remain likely this. But if there is this lithium atom, then there will be two electrons inside this orbit, and this third in second orbit you have this electron. So this electron will feel the screening because of these two electrons inside this. So we need to find that how much charge it is experiencing, how much charge this electron is experiencing here. Means this won't feel this as JEST. Means there will be 3 protons inside this lithium, so it won't experience 3 proton here, it will experience a little bit less. So we need to find that amount, that what will be that. So what is screening is, valence electron here will observe charge less than 3e because nuclei screened by the 2 electrons present in lower orbit's innermost cell. So because it is screened by these 2 electrons. So how can you find this how much charge is experiencing? Just consider this whole thing as one entity, this whole thing, and this electron is outside. So you can consider it like hydrogen like atom. So we need to find that how much positive charge is inside. So we will just apply the formula, same formula, and we will find the value of Z. So this is your En, and this is the potential, ionization potential is given, that is minus 5.39 for the lithium atom. So just put it equal to this, and it will Z effective. So just calculate the value of Z effective, and N equal to 2 because it is in the second orbit. So from here you will find the Z effective 1.26. So it is 1.26 E. That amount of charge or positive charge will be experienced by this outer side electron. Okay, so this will be your answer, 1.26. Next is, hydrogen atoms in the atmosphere of a star are in thermal equilibrium with the average kinetic energy of 1 electron volt. The ratio of the number of hydrogen atoms in the second excited state n equal to 3 to the number of ground state in n equal to 1 is. So we need to find the ratio of the hydrogen atoms with the excited state in 3 or 2. So what is the meaning of this? Means there is this star and there is this atmosphere. So you will find that inside that atmosphere you have hydrogen gas. So each atom will be in different states. Means you can say that some atoms will be in the second excited state, and some will be in the third excited state, and some will be in the first excited state, and some will be in the ground state. So these are kind of atoms you will find around the star. So you need to find the ratio of those atoms which are in the second excited state and the first excited state. So how you can find that? So you know that for a gas you can apply this formula, 3/2 kT. This is the kinetic energy, average kinetic energy equal to 1 electron. This is given. So you can find the value of kT from here, and from the statistical mechanics you know the formula. For N3 it will be exponential minus E3 by kT. This is the energy in the third state, or the second excited state will give you third state, and this is N1, this is your ground state. So this is your formula, you know the value of kT and you know the value of E3 even. How? This is my 13.6 divided by 3 square, and Z is 1, so it will give you nothing here. So it will be minus 13.6 for the ground state, and for third state it will be this. So E1, E3 you can just substitute here, and substitute the value of kT, and you can find the ratio of this, the excited states in the second and the ground state, the atoms. So this ratio will give you the answer. So that is for today. In the next lecture we will discuss some more questions, and then we will go to the Sommerfeld model. So thank you everyone.